Hello and welcome to yet another talk. This time it will be about the recipe for continuous delivery. How can we do continuous delivery effectively in today's world where a lot of things are quite different than they were only a few years ago? So let's start with a very quick introduction about me. This is how I look like. You see me here, you see me there. My name is Viktor and I work for a company called CloudBees. We are known for being a company behind Jenkins, but that's not the only thing we do. We do quite a lot of other things. But since this is not a marketing pitch, I will not go further into, salesy type of stuff. But before that, a quick warning. If you expect to hear me talking about Jenkins, that will not happen. I will talk about something completely different, even though there might be Jenkins in the name, but only in the name. I am also one of the Google developer experts, and I am one of the Docker captains. So you can probably guess that my interests are very focused around containers, schedulers, continuous delivery, and quite a few other things. I also have blog, everybody does, so that shouldn't be a surprise. I wrote a lot of books. All around, most of them around DevOps, one way or another. I have some Udemy courses as well. Follow the link in this presentation. I will provide actually the links at the very end if you're interested to know more. There is another one called Devops Paradox. It's about interviews with people that matter in this industry. It's a bit lighter read than the other books that I have. And I'm a co-host of Devops Paradox podcast with Darin Pope. We have a lot of fun there and I really recommend that you listen to it if you don't have better things to do. I have a Twitter account like everybody does, and that's all you need to know about me. Now, I will skip the next couple of slides because they show how to create a cluster for what I will show you in the demo later on. I already did that, so I will not bore you with you waiting and watching me create a cluster. I did that in advance, but I left them in the slides just in case you want to replicate the same things I'm doing yourself. So let's start with a simple question. What is continuous integration? What is continuous delivery? And what is continuous deployment? And how do they differ from each other? Now, I will not go into details. I assume that these are not new terms, just a brief overview so that we are all on the same page. Continuous integration means that you are pushing things to master fairly often and you're running some automated processes. You might be building something, you might be running some tests, you might be creating some releases, and so on and so forth. Now, the problem with continuous integration is that we know when it starts. The process starts when we push something to the master branch of our repository or one of our repositories, but we don't know where it ends because after that automation comes manual parts, right? After you build and maybe run some tests, maybe some other tests will be run manually, and maybe you will do some other manual operations, whatever those operations are. So it's a kind of half-baked solution which served us well initially, but it's not really something that we want to do today in this day and age. What we are really interested in is continuous delivery, which is very similar to continuous integration in terms that when we push something to the master branch of our code repository, it could be in other branches as well, but master is the most important one, then we run a set of automated steps. We have automated process. Now, the major difference is the end of that process. While continuous integration assumes that you do some manual tests after your automation, with continuous delivery there is nothing manual. Actually, there is one thing manual, but I will get back to it later. Everything or almost everything is fully automated. Once you push that change to your Git repository, there is nothing else for you as a human left to do. Now, I said that there is one manual step with continuous delivery, and that is deployment to production. So everything is fully automated, but we, like humans, make a decision when do we want to promote something to production. And this is now the important thing, that is a business decision. Because if everything is fully automated, then every single build, every single execution of every single pipeline produces production-ready release. And we still have that manual step because we might want to decide when do we want to release to production. Not what. We know what we want to release to production. Every successful build or every successful pipeline will result sooner or later being deployed to production. But we might want to have that button that somebody clicks so that business or whomever makes those decisions can make a decision. No, our users are not ready for a release to production today. Maybe we have a marketing campaign that starts tomorrow, let's say, and then tomorrow we're going to press that button. And continuous deployment is almost the same thing as continuous delivery, except that it doesn't have that button. What that really means is that every time you push something to the master branch, it is automatically deployed to production, meaning that it will run all the steps it needs to run, like building, testing, what's or not, and at the end of that process, a release is deployed to production and there is no human involvement whatsoever. And that requires very high level of capabilities of you, of your team, of the whole company to get there. But that is the destination that we all want to get. That is such a high level of automation that we are so confident in what we're doing that the only thing that we as humans are really doing is changing code and pushing those changes to Git repository. And by code, I mean not only code of your application, I mean code that defines your infrastructure, defines your deployments. Code is everything. And once we push it, it gets deployed to production after usually a large number of fully automated steps. But you already know all that. So let's move forward and talk about what do we expect from continuous delivery today. Because today the situation is very different than it was in the past. While we could do things in a certain way maybe a few years ago, 5 years ago, we cannot expect to continue working like that today anymore. And today we have a certain set of requirements that everybody needs to follow or should follow. And first thing is that we are all going cloud native. And now let me clarify that. When I say cloud native, I don't mean public cloud native. You might be running on AWS, you might be running on Azure or DigitalOcean or Google, but it could be on-prem as well. Cloud native principles and ideas can be adopted no matter whether you're in public cloud or you're on-prem, as long as you follow certain principles like you're making things highly available and fault tolerant and on demand and everything is a service. You are cloud native and everybody's going there. That's a requirement today. It's not a wishful thinking. It's not something that we would like to have. It's something that we must have. And that brings us to the next one, and that is that everything also needs to be cloud agnostic. We don't want anymore to be in the same situation like we are right now or when we were with mainframes or what's or not, that we do things that make us so depending on certain vendor or certain platform that we are never able to escape from that anymore. Or at least if we are going to be tied to something, let that something be open and open source preferably, and place where that we can contribute and from which we can take over control if needed and so on and so forth. So cloud native and cloud agnostic are very, very important things that we should all be aiming for. And then everything needs to be scalable. Everything needs to run when needed and not run when not needed, because we are paying for that compute power. And even if you say, no, I'm not paying for it, I have it on-prem still, we don't want to use compute power for nothing, because we want to have everything we need, but not more. So if right now, for example, you're listening to me talk to you and you're probably not running your pipelines, for example, because you're in a conference, right? Or you're looking at me online and what's not. And when you're not using those things, they should scale to 0. Because some other processes might need those resources, that compute power, and you would be wasting it if you don't scale to nothing. And similarly, if suddenly there is a surge in traffic or surge in demand, it should scale from 1 to 2, 3, 4,000 replicas, 1,000 servers, and so on and so forth. So it needs to be highly elastic, scalable, in a way that it gets everything it needs, but never gets more than it needs. And when it's not running, it's using no resources. That's the ideal situation that we are striving for. And we can call that serverless, we can call it something else. I prefer to call it highly scalable. From nothing to something and something back to nothing. Next thing that we already know, all of us know, is that everything needs to be defined as code. Gone are the days when we would accomplish our work by clicking buttons without knowing how to write code. And we know today that code is the only thing that matters, at least in our industry. And our industry is almost everything. So everything needs to be defined as code. It doesn't matter whether that's code of your application, that's code. Tests, that's code. Configurations, code. Infrastructure, code. Everything is code today. And if it's not defined as code, then it's really a terrible solution. Needs to be very fast, right? Your pipelines, your processes, everything needs to be extremely fast so that we don't spend time waiting and we get that feedback that we need, whatever the feedback is, extremely, extremely fast. We cannot anymore wait until our processes finish after hours or even days of running. That's just silly. That's not the world we live in. And finally, and this is very important one, it needs to be extremely, extremely easy. I cannot expect all of you to know everything. That would be just silly. If you're, let's say, Node.js developer, you're not going to spend 3 years learning Kubernetes. Or if you are a Kubernetes expert, you might not spend a year learning something else. So we all try to focus on whatever is our job. And we are all trying to have a big picture and understand everything else. But that understanding of everything else has limits. And we need to make things simple for everybody. Simplicity is hard. It's easy to make something extremely difficult. Making things easy, it's what makes what proves that the solution is really, really well done. So that everybody can use that something independently of their level of knowledge. So how did we think of those things as being our requirements? That's something that we, when I say we, community behind the project that I will show you later, sat down and said, okay, what should be our requirements? And we came up with that list. And that's easy, kind of everybody can create a random list of stuff. But the real challenge is, how did we accomplish that? And we had to make quite a few different choices. First of all, we assume that everybody is or will be running Kubernetes because it is a cross-platform cloud-agnostic container scheduler, because it allows us to avoid being locked in, it allows us to run anything we want, and it allows us to simplify greatly many of the operations we had before. And on top of that, it's open source, its API is completely open to everybody, and it's almost certainly the future that we will use to when I say we everybody, to base most of our workloads in, if not today, but then at least very, very soon. We also adopted Tekton as a most likely standard for or a serverless solution that will become a standard for running pipelines in Kubernetes. It is very low level, so you're unlikely going to use Tekton yourself directly, but it is most likely going to be the standard, just like deployment in Kubernetes is a standard for running serverless applications, and stateful sets is a standard for running stateful application, and service mesh is standard for networking. That way, Tekton is a standard to run pipelines in your Kubernetes cluster and make them serverless. And then we had to create a ChatOps gateway between all the different components, because we do believe that Everything should be documented, and that doesn't mean that only code should be documented, but communication between us. And that communication needs to result in certain actions being performed somewhere. When I say, can you please review this pull request for me? That text, that comment should automatically assign the pull request to somebody. Or when I say this looks good, let's merge it to master, it should automatically merge things. So there is a great power and great needs for something like that, for being able to communicate and record that communication, create actions from those communications. We adopted Helm as the most widely used standard for packaging Kubernetes applications or whatever we're running in Kubernetes. And finally, quick starts. I will show you quick starts in a minute or two. So what we did really when we started the project, and that project happens to be called Jenkins X, don't get confused with Jenkins. This is something completely different. We took all the cool tools and all the necessary tools, all the tools that we believe are a must today, and put them in a very easy to use bundle. So it is not a project that is written 100% from scratch. We don't want to reinvent the wheel. We are using projects that are doing a great job and then putting glue around those projects that you will see soon. It is CLI first experience, meaning that first we design communication with whatever we're working with, APIs and CLI, and then UIs are a secondary citizen. And that might sound awful, but that's how the world works today. And it is very opinionated. You will see in a couple of minutes how opinionated it is. We believe that there isn't 50 different ways to do something. There are a couple of ways to do any given task. And we are trying to find the best opinionated process that would fit into most people's workflows. As a result of that, we also created a cloud continuous delivery foundation that is now, it is similar to CNCF. It is a host for continuous delivery tools and processes and companies, and we are all collaborating together to make some sort of standard and bring some sanity into madness that we see in that market today. So the real question for you is, are you a Kubernetes ninja? Are you an expert? Each one of you looking at me right now, are you an expert in Kubernetes? Do you know how to create Helm charts? Do you understand the intricacies of Tecton? How about scaffolds, chart museum, K-Sync? How about configuring GitOps and ChatOps? Do you expect everybody in your company to know all those things and many others? Because if you don't learn whatever you see on the screen right now and many other things, you'll not be able to be competitive in your projects. You will not be able to be competitive against other companies, because that is the world we live today. And do all your projects employ continuous delivery? Because if they're not, you're wasting your time on silly tasks, on silly things that don't bring tangible value. And if the answer to any of those questions is no, then how do you plan to be competitive today? How do you plan to get on top of your competition and be better with them, and be better than them? If you're not jumping on those trains, if you don't understand those things because they do, or even worse, they may be already planning the next steps or working on next steps that you don't know. So what I'm going to show you is Jenkins X, which greatly simplifies all those things and many others. I will try to go through a demo relatively fast because I don't want to bore you with details. I will try to do a complete workflow of an application from day one, from me wanting to create an application all the way until it is running in production. So let's jump into them. I talk too much. I get nervous if I don't touch my terminal for a long period of time. So let's jump into a demo right away and see how that looks like. I need to change. Here's my terminal. Excellent. So let's say that I want to start a new project right now, a new application that will be a killer app that will destroy my competition and what's not. So I'm going to use a terminal to do that. I want to create a new quick start. quick start. And what do I need? I need to select language. So I will be coding my new project in Golang, right? And I need to decide the name of the project. So let's call it project name. Let's call it JXGo. It can be any name you want, right? And let's run this and see what we're getting. Right. So remember, while waiting for this, I am starting a new project from scratch and I have nothing. The only thing I have is my cluster and my laptop. Nothing else, absolutely nothing. So it asks me a couple of questions. Do you want to use Farcic as your Git username? It figured out that I am who I am, so I'm going to say yes, I want to use my user. Who is the owner of the repository? I will say I'm going to use this organization. What will be the name of the repository? Let's call it JXGo, just like the name of the project. And now what is happening is that JenkinsX will let me answer this question as well. Do you want to initialize Git now? I do. What will be the commit message? Default, default, default. So right now JenkinsX is trying to use the information I provided to create everything I will ever need to work on a project based on Go. It could be Java with Maven, it could be Java with Gradle, it could be Node.js, it could be Python. It can be many, many different things. I chose Go because I like it, but you need to trust me that I could have chosen any programming language and any framework that is supported by the community. And even if yours is not supported, then you can easily extend that through your own means. So I created a new project. Quite a lot of things happened. I will show you later, but remember that I started from scratch. I don't have a Git repository. I don't have files. I don't have anything, or I didn't at least. So let me put my GitHub user in a variable so that I don't need to type it again. Okay, so let's take a look at my GitHub account and see what we got. So this is the repository that was created for me a minute ago, and you can see that I'm not lying because you see the timestamps here. 1 minute ago. Let me make that bigger. Here you go. 1 minute ago, a bunch of files were created. I have a new repository that didn't exist a moment ago. It is private. It could be public, but I don't trust you, so I'm making it private. And that repository has all those files. Remember what I said, everything defined as code. This is true here as well. So it created a bunch of files. I'm going to show you files again, but this time from my terminal because I have a local copy. It created a local copy of everything I have. So let's take a look at what we got. We got Docker file because the system needs to figure out how to build container images. Even though we are not using Docker in cluster, building with Docker is a terrible, terrible idea. We have make file because this is Go and Go like smake. It could be build.gradle or npm something, doesn't matter. It has a file that has a list of owners of this project who can collaborate with me on that one. It has charts, which is where Helm definitions are. That's how we use Helm to define applications, all the aspects of applications. It has JenkinsX YAML, which defines the pipeline that runs the full automation of everything I need, you know, building, testing, creating releases, deploying what's or not. Source code of my application, scaffold, which is a way how to combine building container images and deploying them and creating different profiles so that if you do it slightly differently locally than in a cluster, you can do all that with scaffold. I don't have enough time to go through all the details of all those files. We will go, instead I will jump directly into proceeding. So you just trust me for now that everything was created and everything I will ever need to work in Kubernetes is there. And it's defined as different files depending on the applications we are using. Now, if I go to the webhooks of my newly created repository, you will see that not only that it created the Git repository, and not only that it created all the files we need, and not only that it pushed things to that Git repository, but it also created a webhook so that every time anyone with sufficient permissions pushes a change to this repository, that repository will notify my Kubernetes cluster, which will do whatever it needs to do to make a sufficient change in the cluster. So let's go back to my terminal. Let's take a quick look at kubectl get pods. These are all the different components, let's call them, that were installed for me. They were installed automatically. I don't need to worry about all those things, except that you can see that a few pipelines were already executed. So let's take a look at what JenkinsX did for me so far. JX get activities. I want to retrieve activities or information about what's going on with my application JXGo. And I want to watch those changes. And we can see that actually, there we go. The first pipeline of my new application, JXGo, is already finished successfully. It executed a bunch of different steps. Everything that basically I need when I push something to the master branch, it was already executed the moment I created the project. And if you want to see more details, you can say JX get build logs for the application JXGo. And here I can see all the details, everything that it did for me. This is the log of the first and the only pipeline that was executed so far. So speaking of pipelines, let's take a look at the pipelines we have right now in the cluster. And we can see that there are actually more than one. I don't have time to go through those three. They're very much related to GitOps. I will actually, what matters for now is that JXGo, owned by me, and pipeline exists, and specifically pipeline related to the master branch of my newly created application. And that brings me to the environments, JX get environments. Let's take a look at the environments. They're very important. I have three environments. Development. This is where all my builds and all my testing and everything related to my pipelines is going and running. And I have staging and production. I could have other environments. I could have integration, pre-production, what's or not. But for now, at least in this case, only two of them. And what makes them special is that staging is set to auto promotion. And what that means is that every time I push something to the master branch of any of my applications, they will be automatically deployed to staging. While production is manual, meaning that we are doing continuous delivery, not deployment, I will make a decision when to promote something to production. And also we can see that we have source, which is a Git repository. So each of those environments has an associated Git repository that defines the desired state of those environments. So it's fully GitOps. Nothing gets deployed or nothing happens in the cluster without changing something in Git or somewhere. So let's take a look at JX get applications. Which applications do we have in our cluster, in my cluster? And there is only one, and that one is the JXGo. And you can see that while I was talking, the first release of my newly created application, 0.1, is already running in staging, and it is accessible through this URL. I will get back to that URL in a second. Now, one more thing I want to show you is that, among other things, even the release in GitHub was already created for me as well. So really the full process, everything, absolutely everything related to life cycle of my application is done out of the box. And the only thing I did so far was create a new quick start, nothing else. Now let's go back. I'm going to define a variable with this address. This is auto-generated address, and I want to show you that if I send a request to that address, staging URL, what's wrong? I made a typo somewhere. There you go. If I send a request to my application, it is already running, and I'm getting a response, hello world, blah, 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 from my application running in staging, and I still haven't done anything except create a new quick start. Everything else I showed you is just to show you what's happening in the background, but the only real action was to decide to what I want. So now you don't really need to know all of those things. What you really need to know is that you as a developer, you as operator, maybe a different story as sysadmin, but you as developer, the only thing I expect from you is to write your code and push it to Git. Those are the only two requirements I have for you. Write code, push to Git, and the system will take care of absolutely everything. And just give me a second. I got confused with my notes. Here we go. So now let's see how all that works from a developer perspective, right? I'm going to go to my newly created application, and I'm going to start working on a new feature. Me, myself, and I. New feature, I'm going to check out a new branch, my PR. And I'm going to simulate that I write code by going to main.go, and I'm going to change this to something else. Let's say my new feature was to output blah, blah, blah to as output of requests. So as every good developer, I'm going to add this to the code. I'm going to commit something, and I'm going to push that to my newly created branch. I'm doing right now something that every single developer does. I'm not doing anything new. This is nothing really special. You are all creating branches, you're changing code, and you're pushing to those branches. And now I'm going to create a pull request. I'm using command line for that, but if you go to GitHub or GitLab or whatever and create a pull request there from UI, the result is exactly the same. And I'm going to go to my pull request and say, okay, can you please review this this pull request for me? And somebody should not be notified about this pull request, right? So let me assign this to, can you please review this for me? Assign to this guy. And if I make this comment, this is now ChatOps in actions. I will be assigned. Look at this. Nobody is assigned to this pull request. And a moment later, I am assigned to this pull request. So I can communicate with my team, and part of that communication becomes actions. And you can see here that there are certain rules that we decided to follow in this project. We can, for example, say silly things as well. Let's honor kittens. Meow. Basically, there is a huge set of commands that can be used as / commands. And there you go. There's a kitten for you. Finally, let me not waste your time. Let's imagine that we pass the process, we review the code, we run our tests, we did whatever we need to do. This is ready. Let's merge it. We're going to LGTM. Looks good to me. Imagine that I'm the one reviewing it. And few things happened, 2 things in parallel. I'm going to go back to merging it, but you can see that my pull request is already built and available in preview environment, and I can click here and see my newly created application. Look at it. This is my application deployed while I was talking to you in a temporary environment that is available only for this pull request, and it will be removed when the pull request is finished. And I will approve this pull request. And the system says you cannot approve your own pull request, which is normal. I should assign it to one of my colleagues. I should never, never, ever approve my own pull request. So I'm going to bypass the security and say, yes, I want to merge. And now, once I merge, so remember, the only thing I've been doing is interacting with my system by writing messages in GitHub. While in the background, JenkinsX is working very hard to accomplish everything I need. And one of the things it is doing is that the moment I merged my new feature to the master from the pull request, it immediately executed a pipeline, started running a pipeline that will ultimately deploy a new release to staging. And now I need to wait for a minute or two until this is finished. So it is running all those steps, blah, blah, blah. It is doing everything it needs to do. And ultimately it will be deployed a new release to staging. Now, in interest of time, let me see how much time I have. In the interest of time, I will not wait until my new release is deployed to production. Instead, I will just imagine that I was patient enough, and that happened in the background. And I will jump straight into one more thing I want to show you before my time runs out. You need to remember, new release 002 will be running in staging in a few minutes time. So after this is deployed to staging, the only thing left for me to do is to say that I want to approve and to run it in production. And to do that, let's take a look first what is running in production. Applications in production. Right now, there is nothing in production. There is JX Go, but no releases are running in production in any form or way. And if I take a look at what's running in staging, I can see that the release 001 is running in staging. Remember, the one that I just merged to the master branch did not finish deploying to staging. It will be deployed there in a few minutes' time. So instead of waiting for the second release to be deployed to staging, I'm going to just promote the first release to production. And how do I do that? I can say I want version 001, and what I really want is to promote it to production. So this is the command. I was too fast, that was executed, saying that yes, I want to promote application called JX Go, and that specific version of the application to the environment called production. And right now the system is working, and soon in a few minutes time it will be running in production. And the way how it is working is that this command is not deploying anything to production. So this command is not touching my cluster. Commands never change your cluster. What it is doing is that it went to this repository. It created a pull request in the repository that defines my production environment. And this pull request looked like this. Now ignore all this because this is a formatting change. What it really did is that it added this entry to the repository associated with production. And that creation of that pull request initiated a pipeline that validates whether that pull request to change production is valid. And right now that pipeline is running. And soon it will be finished, and this pull request will be merged to the master branch of the production repository. And when that pull request is merged to the master of the production repository, it will be deployed to production. And yet, the only thing I was doing all this time was changing code and pushing something to Git. I could have accomplished exactly the same result. I could say, okay, I don't want to run even commands. If I went to this, let me wait actually until this pull request is merged. It shouldn't take long. Come on, come on, come on, come on. It's so funny that a few years ago, I mean 10 or 5 years ago, I was If something happens within a week, I was happy, now I'm getting impatient. There we go. This pull request is merged automatically to the master branch, and that started a new pipeline. And I can show you that if I go to the repository defines my production, if I go to requirements YAML, I can see that now this is in the master branch. And if I would like, I could now deploy release 002 just by changing this. If I would commit, push this change, then production release would change from 001 to 02. In other words, I'm controlling everything through Git, even though I'm showing you things in a terminal. And let's take a look at the applications. There we go. We can see that JXGo is running release 02 in staging because it was automatically deployed to staging, and this is the address through which it is accessible. And I promoted release 01 to production, so therefore that's what is running there, and it is also accessible through this address. And if I send a CURL request to that address, demo hello, no, I should get the message. So my first release is deployed to production, and I could deploy the second one as well. So production is running release 01, and staging is running release 02. And you can see that the messages are different. And that's about it. I think that my time is out. Yeah, 42 minutes. I don't know how this works. Do I have time for questions? If I do, I'm going to answer all your questions. Thank you so much. Oh, yes. Before anybody goes anywhere, let's do this. There is a thank you message. Thank you so much for listening to my stuffy. Check my blog. This is the address. You can see it from there. Go and listen to the podcast. I think it's really cool. We have a lot of fun with it. And Devops Paradox book is available. You can snap QR picture. And this is a bunch of other books and courses I have. I use the money from those books all go into buying, exclusively 100% into buying pizzas and Red Bull so that I can do more of those things at night when I'm not doing my office work. So you can think of it as being a good cause. You would be feeding me with pizzas so that I can write more and giving me Red Bull. Thank you so much. It was a privilege to speak to you in these difficult times. If I have time for questions, as I said, I will answer them right now. So let's go through a few questions that we have here. So the first one says, I know that JX is opinionated to multi-repo. Is monorepo better approach to microservices? Will JX ever support monorepos? So the short answer is yes. We are working on two directions for monorepos. No, actually, let me backtrack a moment. Yes, we are opinionated and we prefer multi-repo. Now, that does not mean that monorepo is not a good choice and that it is not supported. It is, or to be more precise, it will be. For now, there is already one solution available, and that is you can use JenkinsX to split your monorepo into multi-repos, which I guess is not a good option for everybody. Some people will want to keep monorepo. And in that case, the solution is coming. We are working on it. I cannot commit to any specific date. But yes, we are working on a monorepo solution that does not require us to split with or without JenkinsX monorepo to multi-repo. And if I don't answer any question fully, just let me know in addition through additional comments, and I will answer it better. So the next one, can we possible get continuous deployment with JX multi-repo opinion, how to release independent services at the same time? The answer is yes. So in our world, everything is controlled through Git repositories, and you would have Git repositories for each environment or a cluster, like staging, production, and so on and so forth. Now, what you ultimately want to do, if you want to release multiple applications at once to one of those environments, you just go to repository, add or change multiple releases in that repo in a requirements.yaml file. And if you push a change with multiple releases at the same time, then they will be deployed at the same time as well. Now, when I say at the same time, there is no guarantee in Kubernetes Pro that it will be exactly up to a millisecond same time. But to be more precise, Kubernetes will receive information that you want to deploy multiple releases at the same time, and then it's up to Kubernetes to do it again at more or less the same time. Nothing can ever be exactly the same time. So what next? We have, is the full feature set of Jenkins X supported for Bitbucket as well? Almost full feature set. Now we have a problem with Bitbucket, which is actually a problem of Bitbucket itself, and that is that Bitbucket, the older releases of Bitbucket do not really distinguish pushes to a pull request compared to other branches. So the only issue that I know of right now for Bitbucket is that when you create a pull request, Jenkins X will do the right thing. But when you make additional changes to existing pull request, Jenkins X or anybody for that in that sense will receive from Bitbucket valid information about those changes to existing pull requests. Now, a new version of Bitbucket, I don't remember the version number, but new that was released, I think, a few days ago, improved that. So Bitbucket in the latest release does send a valid webhook when you push changes to existing pull request, and now that should start working if you have a new version of Bitbucket. And I think that those are all the questions. If you have anything else, I would be happy to answer. Okay, so no more questions. I don't want to keep you looking at me for longer than necessary. So thank you very much for listening to the talk. Thank you very much for the questions. Goodbye and stay safe.